Hello and welcome to GeoEd with Abhisek. In the last class, we have talked about rotational symmetry, in which we have talked about the axis of rotation, different axes of rotation, one-fold, two-fold, three-fold, four-fold, and six-fold. In today's class, we will talk about the other two elements, which is the center of symmetry and the mirror plane. For center of symmetry, the symmetry operation is the inversion. Inversion is the operation and the element will be center. Center of symmetry will be the element, symmetry operation will be inversion. Similarly, for reflection, reflection is the operation and this mirror plane is the element. Okay, mirror plane will be the element and reflection will be the operation. So first we will talk about center of symmetry or inversion symmetry. Every crystal is having a center because it is having perfectly developed faces, edges, and solid angles. It is having a center. But if that center is showing symmetry or not, that is the question mark. Every crystal will be having center, but every crystal may not have the center of symmetry. What is center of symmetry? Suppose this is the cube which is having a center. Inside there is a center. With respect to the center, in the opposite direction, if we are having similar elements, like for example, if I am holding this solid angle, this is the solid angle. This solid angle is present here and the center is somewhere within the crystal. With respect to the crystal center, if this solid angle is present opposite to it, that means this one, opposite to this solid angle, there must be another solid angle. If we are talking about one edge, suppose this is the edge, this is the edge. With respect to the crystal center, if this edge is present, opposite to it, we should have another edge. Then we will call it that the center is having symmetry, or the center is showing symmetry, or the crystal is having center of symmetry. For this crystal, if there is a face here, if this is a face, what we are seeing, with respect to the center, in the opposite side, we must have another face. Suppose here it is a face and here it is the crystal center. In the opposite side at equal distance, if we are having another face, then we will call this center is symmetric. If there is a solid angle here it is the solid angle. With respect to the center, suppose this solid angle is present at d distance with respect to the center. In the opposite side, if we are having another solid angle, here we are having another solid angle, then we will call that this center is having symmetry, or the center is showing symmetry, or we can say the crystal is having center of symmetry. So what happens in center of symmetry? It is basically inverting the structure. How? This is the example. Here you can see the digit 6. This 6, if it will be inverted through the center, it will become 9. The 6 becomes 9 after inversion. For example, if this is the pen and this is the center, okay, this is the pen, you see the top portion is here, this is the bottom portion, and if the center is here, and if the center is symmetric, or if we have to invert this pen with respect to this center, then it has to be like this. The top portion becomes bottom portion, the bottom portion becomes top portion. This is called inversion. Top and bottom will become opposite. Okay, this is called inversion. So that's how the 6 becomes 9. This is inversion symmetry, or we can say this is the center of symmetry, which we represent as I. Now we have studied rotation, then we have studied inversion. Okay, now we'll go to the reflection. What is reflection? When we stand in front of a mirror, the left side becomes right and right side becomes left. If you stand in front of a mirror, like now also, if you are seeing me, for me what is my right hand, it may appear you to left. Okay, like I am now showing my left hand, it may appear right. In crystal or in crystallography, reflection symmetry is also like that. If we have a mirror plane in between, see here this digit 6 is appearing like letter D, somewhat looking like letter D, because of reflection, which is the right side that became left and which is the left side that became right. This is how the reflection symmetry works. Okay, the symmetry element is the mirror plane. This is the element and operation is the reflection. Okay, we represent it in M letter, which stands for mirror. So it will reproduce the motif, means the face or the edge or the solid angle. It will be reproduced, but the side will be changed. Okay, left side will become right and right will become left. Whatever we have studied till this rotational symmetry 1, 2, 3, 4, and 6, these are congruent operations. We call it congruent operation. Why congruent? Because in the rotational symmetry, the phase will be repeated as it is. Means, suppose I am rotating, this phase will be repeated as it is. There is no change in side, like right will not become left, left will not become right. Similarly, top will not become bottom, bottom will not become top. In the rotation, this is the phase, this is the top portion, this is the bottom portion, this is the right and left. If we rotate it, if this crystal is having rotational symmetry, this phase will be repeated as it is, means top will be top, bottom will be bottom, right will be right, left will be left. Means there is no change in side, there is no inversion. Okay, in rotation, the repetition is as it is or same as the previous phase. The repeated structure or repeated motif is same as the previous one. That's why we call it congruent operation. But the reflection and inversion, they are called enantiomorphic operation. They are called enantiomorphic operation. Why enantiomorphic? Because in inversion, top will become bottom and bottom will become top. Similarly, in reflection, left will become right and right will become left. Because there is change in side and because there is change in this top bottom. That's why we call it enantiomorphic operation. Whereas rotation produces identical faces, so we call it congruent operations. So far we have studied about different operations individually. Now we can also combine, we can also make combination of rotation and reflection, and we can also combine rotation plus inversion. Okay, so rotation means, let's say we have studied one fold, two fold, three fold, four fold, six fold. Okay, along with this, if we will add one mirror, what will happen? Along with this 1, 2, 3, 4, 6, it will add I, the center of symmetry, what will happen? What will be the resultant? That we are going to see now. First, we will go to rotation plus reflection. So, the first rotational symmetry we are taking is a twofold rotation. Twofold rotation, along with we will add one mirror plane. One axis of twofold, which we will represent like this. One axis with twofold rotational symmetry. We will combine that with a mirror plane. So here, this is the axis which is showing a twofold symmetry. Along with it, I have taken one mirror plane. This is the mirror plane. Now this is the digit 6. Either we can go like rotation then reflection, or we can get reflection then we will rotate. Okay, in any way we can go. First we will rotate, then we will reflect, or opposite also we can go. First we will reflect, then we will rotate. Okay, So first we will reflect. So this 6 will become T-like structure like this. Okay. Now this entire structure, because there is a rotation axis at the center, this entire structure has to repeat after 180-degree rotation. Twofold rotation means we have studied. Twofold rotation means in 360-degree it has to appear twice. In 360-degree it has to appear twice. That means at each 180-degree rotation we will find identical structure or identical motif or face or edge, whatever. Okay. So this entire structure has to repeat after 180-degree. This structure came after reflection. For 6, if I reflect, it will become D. Now this structure formed. This structure has to repeat second time after 180-degree. So here this is the repeated face. This is the original. This one is the reflected. Then after reflection, this will become one single unit, and the center of the axis of rotation is here, so it has to repeat after 180-degree. So it repeated again after 180-degree. We will reach the initial position. Okay, so this is the rotation. Okay, so now the structure is like this. Now the structure is like this. Now if it is complete, we have taken a twofold rotation axis and a mirror plane. We found this structure. Now is it complete? Is there anything missing here? You see this digit 6 and this structure, they are also appearing like mirror. If I will take them closer like this is 6 and this is like this. They are also looking a mirror, like a mirror is in between them. They're also looking like reflected one. Similarly here, if we will see, this is the structure of D, and here at the bottom we are having this structure. Now if we will see the top one and bottom one, they are also appearing like they are mirror image. That means there is something missing here, which is a mirror plane, which is another mirror plane. We started with one single digit 6 and one mirror plane, and at the end we found that it is bringing another mirror plane also. So we started with 2 and m, we got 2mm, which is a class in orthorhombic system. We will study it in details. This is a class of orthorhombic system, whether you call it 2mm or you can call it mm2 according to different books. I will also explain why it is 2mm, why it is mm2, but that we'll discuss later when we'll study 32 class. Okay, so in orthorhombic system, this is the class where there is a twofold rotation axis. There are two mirror planes. There are two mirror planes. So first there is a twofold axis we have taken, we have combined with one mirror and it resulted in another mirror. So 2m is not possible. 2m is possible. If we will try for 2m, it will result in 2mm, or in other words we can say mm2. Okay, this is the final structure. This is the final structure. We started with twofold rotation axis and one mirror. We resulted in 2mm or mm2. Okay. Then this is the point group name. Okay. Then we'll go for a fourfold rotation axis, one axis of fourfold symmetry plus one mirror plane, plus one mirror plane. Now let's see what will happen. So as I told, either you can go by rotation then reflection, or you can go by reflection then rotation. So here, as it is the fourfold rotation axis, it will repeat at each 90-degree rotation. Means in 360-degree rotation, we have to repeat the structure 4 times. That means at each 90-degree rotation, we will find another symmetric face or symmetric structure, or the motif will be repeated another time. Okay. So first we'll start with reflection as we have done in the last one. So 6 will become D. Okay. Now this becomes one single structure. Now this is one single structure. Whatever structure we are finding, we have to repeat it 4 times because in the center we are having a fourfold rotation axis. So this entire structure has to repeat 4 times. This is the second one, this is the original, then this is the reflected. Now this become one unit. This is the second repetition. Then third repetition, and then fourth repetition. Okay, this is the first one, second one, third one, and fourth one. So we started with 4 and 1 mirror plane. We started with 4 and 1 mirror plane. Now we are having what? We are having a fourfold axis. Here it is 1 mirror plane. Here it is 1 mirror plane. So we are having 4 plus 1 mirror plus 1 mirror. We have taken 4 and 1 mirror. We found another mirror. Is it all? Is it finished? No. If we see this structure, this and this, they are also appearing like one mirror image. If we see this and this, they are also appearing like mirror. So this mirror will continue like this, and this one will continue like this. So this structure and this structure, they are also looking like mirror plane. Similarly, this one and this one, they are also looking like mirror. If we see this and this, they are also looking like mirror. They are also reflected. The left becomes right. Here the left becomes right and right becomes left, like that. Okay. So we started with one single fourfold rotation axis and one mirror plane. But what it becomes? We started with 4 plus m, but it resulted in another m here and here 2 mirror plane. Means 4 m, m, m and m. Means 4 mirror plane. One fourfold rotation axis we combined with one mirror plane, but it resulted in one fourfold axis and 4 mirror planes. So what will be the name of the point group? Is it 4 m, 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 m? Is it the point group name? No. Here it is 4 m, m. Why 4 mm? Why instead of 4 m's? Why I am writing 2 m's? Because if you see, this class is from tetragonal system. This class is from tetragonal system. Fourfold rotation axis, either you will get in tetragonal or you will get in cubic system. Okay. Fourfold rotation axis means either you will get in tetragonal system or you will get in isometric system. This 4 mm is a class of tetragonal system. How I am knowing this 4 mm is a tetragonal or cubic? How I am knowing this? You will also get to know when we will study 32 plus. After that lecture, no need to worry. You can simply see the symbol and tell the system, and you can also tell the name of the class. Okay, no need to worry for that. We will discuss that. So for now, what is our question is why it is not 4 and 4 m's, why it is 4 and 2 m's? Because this mirror plane, this orange one and this orange one, these two are axial mirror planes. In a tetragonal system, Suppose this is a tetragonal sketch is a this is an example of tetragonal system where A1 we know what is the axial relationship for tetragonal system. A1 is equal to A2 not equal to C. That means the horizontal axis A1 and A2 are the horizontal axis. One is front to back, one is right to left. The horizontal axes are equal in length and the vertical axis is unequal in length. Okay, and the vertical axis will be fourfold symmetry because it is tetragonal. The vertical axis will be fourfold symmetry, and A1 and A2 they will have twofold symmetry. That is in the normal class. 4 is not a normal class. Okay, it is not a normal class of tetragonal system. So it is having C axis fourfold, and this A1 and A2, this is the crystallographic axis. These two orange lines, if you see the two orange lines, they are connecting the faces. They are connecting opposite faces. Suppose this is parallel to A1 and this is parallel to A2. Okay, this is parallel to A1 and this is parallel to A2. That means two mirror planes, they are parallel to the crystallographic axis. We will call it axial mirror planes. We will call it axial mirror planes. Another two mirror plane, which is, you can see they are connecting the edges. They are connecting the edges. Means one axis, that two mirror plane, what axial mirror plane is this one. This is one axial mirror plane and this is another axial mirror. Okay, one mirror plane is containing A1 axis, another mirror plane is containing A2 axis. So these two mirror planes are axial mirror plane. What is diagonal mirror plane? This is a diagonal mirror plane, and this is another diagonal mirror plane, which are connecting the edges or containing the edge diagonals. Okay, these are the diagonal mirror plane. So these orange ones are the crystallographic mirror and these blue ones they are the diagonal mirror. Okay. So for axial mirror plane we will use 1m because they are identical. They are not different. A1 is equal to A2. The axes are equal. So the two mirror planes will be also equal. Okay. These two mirror plane, this one and this one, they will be identical in nature. So for them, we'll use two different m's. We'll use one m. One single m will represent the two axial mirror planes. The next m, the next mirror plane will represent the two diagonal mirror plane. We'll not use this one as different and this one as different, but they are identical in nature. So we'll use a single m for representing the two diagonal mirror planes. So one fourfold axis, which is the vertical axis or C axis, one mirror plane, which is the axial mirror plane, and one mirror plane, which is the diagonal mirror plane. Okay, the final point group name will be 4mm. First M will represent crystallographic mirror, second M will represent diagonal mirror planes. Okay. Now we'll go to trigonal system. One threefold axis, threefold rotation axis, and one mirror plane. Threefold rotation and one mirror plane. As we started, similarly we'll start now. This is the initial phase or initial motif, 6 digit. It will be reflected to tree-like structure. First we'll go for reflection. Okay. We have taken one threefold rotation axis and one mirror. The resultant will be this. What is given in your screen, it is the resultant. But we start with threefold rotation and one single mirror plane. So this 6 will become D-like structure. Now this entire structure has to repeat thrice in 360-degree rotation. Because it is a threefold axis, in 360-degree rotation, we have 3 times repetition. That means after each 120-degree rotation, we will have the similar structure, or the similar structure will be repeated after 120 degree. So this is the first one after 120 degree, this is the second one after 120 degree, this is the third one, and then we'll return to the original place. Okay, so we started with one threefold rotation axis and one single mirror plane. We started with one threefold rotation axis and one single mirror plane. Now we have P, M, M, and M. We have three different M's, M1, M2, and M3. So what will be the name of the point group? Is it 3MMM? Can we use 3 triple M? No. We will use 3M. In trigonal system, you must have seen if you have studied. If you have not studied, then we will study later. This 3M, we don't have point group named 3MM or 3MMM. We don't have this name. We have 3 and M. Why? This 3 represents C axis, which is the threefold rotation axis, and this M is for axial mirror planes. This M are for axial mirror plane. As we know that this trigonal system is a subclass of hexagonal system. This trigonal system is a subclass of hexagonal system. This is a hexagon. So for this hexagon, we have a, like, inside the hexagon there is a triangle. This is the symbol of trigonal system. This is the symbol of trigonal system. Trigonal system is a reduced class or reduced subsystem of hexagonal system. Okay. So in this trigonal system, if you see, the first axis is a threefold axis, which is the longest axis or C axis. The next position is belonging to axial mirror plane, means this next position is belonging to crystallographic axis. The next position of the class of the nomenclature is belonging to crystallographic axis. Whatever element is there, they are attributed to the crystallographic axis. There is no diagonal axis in trigonal system. In hexagonal system, we are having diagonal. Okay. So we are not having edge diagonal. We are not having the, like in hexagonal system, 6mm means first is the C axis, which is the unequal axis. The next one is the axial mirror plane or crystallographic axis. The third position is the diagonal axis or diagonal mirror plane perpendicular to the diagonal axis. Okay. So the third position is for the diagonal axis. When we are talking about trigonal system, in trigonal system we will have only 3 and M. The third position is not there because we don't have diagonal. That means 3 axial mirror planes and the C axis is threefold. So the class name will be 3M, not 3 triple M or 3 double M. Hopefully it will be clear. The next example is sixfold rotation and mirror plane. In one axis with sixfold rotation, this is belonging to hexagonal system, and one mirror plane. If we will combine, what will be the result? What you are seeing is the resultant. This figure is the resultant. Let's start as we started for twofold, threefold, fourfold. Let's start here. This is a sixfold axis, sixfold rotation axis at the center, and we have the rotation axis sixfold, and we have one single mirror here. Now the digit 6 will become D-like structure after reflection. Okay. This is the first step. First we will reflect. Then it will become one single unit. Okay. Now because there is a, we start with 6 plus M. Okay. center sixfold rotation and one mirror. Because of one mirror, 6 becomes D. Now this is one unit. This one unit has to repeat 6 times. In 360-degree rotation, it has to repeat 6 times. Means after each 60-degree rotation, it has to repeat. This is the original, okay, or the first one. Then after 60-degree, then it will be repeated. Another 60-degree, then it will be repeated. Then another 60, another 60. Like that, it will repeat 6 times. Okay. After all the repetition, we will see that this structure, and this, they are also mirror image. This and this, they are also mirror image. This and this, they are also mirror image. Here also you can see this and this, they are mirror. This and this, they are mirror. Okay. So then we'll put this blue lines. These blue lines are the mirror plane. These are the diagonal mirror plane. We started with one sixfold rotation axis, which is the C axis. C axis is the sixfold rotation axis. And we started with axial mirror plane. One mirror we have started, then it is repeated thrice. We started with here, then it repeated here, then it repeated here. So 3 mirror planes we have. Then we saw another mirror plane is also there, like here. If let's say M dash, M dash, and M dash. These 3 M dash came later, which are the diagonal mirrors. So we start with 6 and M. We conclude with 6 M, like 6 times M. We conclude with 6 times M, from which 3 mirror planes are axial mirror plane and 3 mirrors are diagonal mirror plane. Okay, C axis sixfold rotation, 1 mirror plane we started with. We resulted with 3 green mirror, means axial mirror, and 3 blue mirror, means diagonal mirror. Okay, so 6 mirror planes, 3 axial mirror planes, 3 diagonal planes. Instead of using 6 and 6 times M, instead of using this symbol 6 MMM, we should use 6 MM. We are going to use 6 MM. First 6 is sixfold, next M is axial mirror plane. This M represents 3 axial mirror planes. The next M represents 3 diagonal mirror planes. I hope everything is clear. So till now we have studied these elements: one-fold rotation, two-fold, three-fold, four-fold, six-fold. This is the rotational symmetry. M is the reflection. Then we tried combination: 2mm, 3m, 4mm, 6m. In the next video, we'll talk about rotation plus inversion, which is roto-inversion. Okay, so stay tuned. Thank you.